Dear students, greetings. In computational science, security is one of the most important element. While we talk about security, why do we talk about security? The reason being, web itself is unsecure by default. For example, when you log on to a website and if you don't see this particular icon, say, let me just type it. So if you don't see this particular icon, it means that by default, the security doesn't exist. So the World Wide Web let's just see. So if your browser tells you if the page is unsecure, it by default means that the SSL encryption that you just saw, this one, connection is secure, right? Is not available. And you have to remember that by default, web or internet does not guarantee any security. This lock or the padlock that it says, right, padlock icon, is an additional security measure that as a developer, you will provide to the client. So if you are developing a website and if you want your client information to be protected, then you have to ensure that the web is secure. Today, I'm going to discuss and start with a course called Basics of Information Security. This is your semester 6 course with course code 4360702. And you have also to know and remember that security and privacy is a very critical part, one of the most important pillar of computational science. So without providing an assurance of the confidentiality of user data, you as a developer and a company as a web application, a web app, a mobile app, or a website can never provide an assurance, can never provide the guarantee to the user that it is secure. So as a developer, this course is a pillar that will help you to introduce security in development of whatever development stack that you take up. So this course consists of 5 different units, wherein you have introduction to information security, you have conventional and symmetric cryptography. There is another version of cryptography which is called public key cryptography. So you have that. And then in the last, a buzzword called cybersecurity, because as of now, what we see physically is also available via the internet, via a layer which is called a cyber layer, where your applications such as smart home or smart metering or smart refrigerations or industrial IoT, all of these smart applications will have to depend upon these fundamentals. So as of the first class, I will walk you through, I'll handheld you through the concepts of information security. Well, my name is Dr. Parvez Farooqi, and I am going to provide you a curated course, a curated introduction of security, since security and privacy is also a very important area of interest to me. Additionally, I also work towards providing security and privacy as a researcher, as an academic researcher, in the interest of web, which was also visualized as an open element, because we all are part of this internet or part of this web, because it was provided to all of us as something which was open. It's not a closed thing. Otherwise, you would have to pay for that. So let me just go through this course. I am head of department information technology at MEPTI Rajkot, and let me just initiate the presentation. So basics of information security. For me, rather than going with the flow of the course, we are actually with the flow of the course. However, we need to have real implementation or real information about the cryptography, which is a methodology, a formal methodology, a mathematical base that ensures that the normal text is readable, and that readable information can also be understood by anyone. That is usually known as a plain text. So when your content travels via web, please remember web or internet is anonymous. When two people communicate, you cannot guarantee by default. Web or internet does not guarantee security. You have to, as a programmer, since you will be programmer in probably 3-4 months now, you'll complete your course and you are going to be a good developer. So as a developer, you must know ways and means to provide two things. Security, that is the assurance to your client that their private information is protected and the sensitive information remains private. Therefore, important to associate security and privacy. So by default, as I said, I showed you one web page. Your web traffic is a secure HTTP, hypertext transfer protocol. However, it is secure. So if you see this, right? If you see this, or if you see anything else, you need to know that by default, the companies would always want its customers to be secure, and therefore an additional encryption layer exists. They provide this. So you as a developer need to remember, you need to do this. If you are using a wireless communication, say your mobile data is a hotspot and your hotspot is being accessed at multiple places. So in that cases, you already know this since you have an IoT course as well. So there's a protocol called 802.11i, which is also known as WPA2, and the wireless encryption protocol encrypts the wireless traffic. So encryption is a way to achieve security of information. Otherwise, by default, the information is usually private. If you talk about mobile networks, you have a GSM networks, right? So even in those networks, the security has to be there. Communication has to be secure because the conversation between two individuals is confidential, and that confidential conversation needs to be protected. An important application that you usually use when you transfer some data from your smartphone to your laptop or desktop through a Bluetooth protocol. So that has to be encrypted. Additionally, your operating system is usually installed on your primary partition. Say if you're using Windows, it's on your C drive. If you're using any other operating system, again, it has its own file system and accordingly it stores the content. So for that, you have an EFS encryption or a TrueCrypt encryption. So this is not a default security because web, when came into existence, was a very small communication network between some universities and Department of Defense in US in the 60s. So though security became very important later on because this network, which was called ARPANET, became something called internet. It evolved into internet and it became one of the most important component of human life after the World Wide Web came up. Now even your discs, your DVDs, your pen drives also have protection mechanisms in form of CSS for DVDs and AACS for Blu-ray discs. And we know the difference, Blu-ray discs and DVDs. When you log on to your web server, when you log on to your mail server, you are the user. So user is a client. User is usually called Alice. Whereas your web server is known as Bob and your server is your email server. So as of now, if you are logging into a mail application, if I'm logging into an email application, I have to remember two things. My browser is actually a content provider, right? My content is provided uh, to users via this particular. So if I look at this, right? If I look at this, by default, there are specific ways to communicate. So if I communicate using one particular law, it would be secure. So web by default does not provide security. But if you see here, you already develop web applications, web pages. So if you see after the question mark, there is a lot of jumble going on and a lot of things, something can be understood, something can't. So all this that you see is usually encrypted, which is traveling via your address bar as a query string. So I'm talking to you, assuming that you have been developing applications, web apps, mobile apps, desktop applications, whatever you are good at. But remember, we need to ensure that security is thought of right from the start. Security is an important pillar of development. It is known very clearly. So if I look at the presentation again, when you are authenticated, there is something which is called a server, which is called Kerberos, and Kerberos is usually a seven-headed dog. So if I say Kerberos, right, Kerberos authentication is a network of authentication protocols which was developed at MIT, and this protocol uses a secret key. Secret is something which is private. So a secret key cryptography to provide secure communication over a non-secure network. So please remember, what's a non-secure network? Internet by default, web by default, websites by default are non-secure. And as a developer, you need to ensure security. Remember this, you need to ensure that it remains secure. So if we go to this diagram, just see, you can see some locks and some keys. So this subject is of fine, introduces you to a lot of things. See now, so if you are accessing your email, what is important with your email is your email ID and your password to log on to your Google email application, to your mail client. So this is you and you are using a browser to log in. So here you have something called a green object, which is called a key. Now, important thing, client authentication to the authentication server. So this is your mail server. When you want to log in, the server always asks for a couple of things. And those couple of things are a username and a password. So without this, individuals cannot log in. If I authenticate myself with some wrong information, say I type in something which is not correct, which is not stored, then you'll always see your information is not correct. When you don't provide this pair, when you don't provide the correct password, you won't be able to log in. So Kerberos is an authentication protocol. Then there are message digestives and a lot of other information that you need to look at. Now, in case of HTTPS, I can just show you a very simple diagram. So let me just show it to you. And HTTPS is default. Fine, it's not a default security. It is actually a mechanism which ensures security when a developer pays for that security. So if a company wants to launch a website and it wants an end-to-end encryption, then it will go for this particular encryption mechanism. Just see this, right? See this, right? So when a HTTPS protocol takes up, it means you pay for this particular services, right? And then you install this on your web application and then it's going to go, right? Remember this. I'll again additionally show you something more. Let me just show you an Hostinger HTTPS. Now you see this. So even such services are available to see if the client is secure or not. Whether this particular client is okay, it is important to even know that, right? So what we need to remember? We need to remember that whatever we do as a developer, we have to ensure that a kind of confidentiality, which is the first requirement of any user, is achieved. Privacy, which is also a very important aspect, or which is an important expectation of a customer, is also achieved. So this particular course of Basic of Information Security has real implications that you just see over in a few examples. Now, by default, for this particular course, you will have 3 different entities with whom you will communicate. And it will always be communicated via something which is called a threat model. Why a threat model? Because web by default is unsecure, non-secure, and therefore there will be someone who is called an attacker or an adversary. Right now, what you see is on the left, it is you, and you as a user is always known as Alice or is known as Alice, right? So Alice is a client who logs on to his browser or who logs on to her browser and ensure the functionality. So if I write www.dtegujarat.gov.in, say, and if this domain exists, right? If this domain exists, I will go. Or if I say DTE Guj, right? DTE Guj. So dtegujarat.gov.in. So when I go here, right, it's taking some time to respond, but it surely will, right? So similarly, when I look at this particular website, right, this is your All India Council for Technical Education, which is a monitoring body. So if you see, it is by default an additional SSL for which it is paying, but still the user data which travels needs to be protected rather than only depending on SSL. So when I typed in this message, when I was here to show it to you, right? When we are looking at this aspect, you are the client, right? You are the client. See this. So you are the client known as Alice. Who is the server in this case? So if you look at this slide, there is someone called Bob. Bob is the server. So if we look at the same example, Commissionerate of Technical Education website, this website which is hosted on a web server is your server, and server is usually known as Bob. So right now, a client called Alice is communicating with Bob. A user is communicating with the server. So these two entities will be recurrently called up. These two entities will be used for explanation. And when you see a arrow moving from Alice to Bob, it's written public channel. So what does this mean? This means you are on internet. And by default, internet is a public network. It's not a private network. And when it's a public network, by default, it guarantees no security. So Alice has a message to send to Bob. her username and password to log into the website, the one that I showed you right now. Something that I showed you right now. Just let me again open it. So when I do this, and when I go to this mail server, the reply that I get here, right, is from the server. So server is now, I requested the server for Gmail. It responded with this homepage. So now I need to add a password, or if I want to log in as some other user, I can always do that if the name is not visible. So right now your client has remembered you. Therefore, there was an email by default by which it was asking for a password, but you can always have a new email ID. So as a client, you request, server responds. So Alice is a client, Bob is a server. And as I said, there is always a third person, an individual who will always be known as an attacker or an adversary. Alice and Bob are two parties who are doing a legitimate confidential transaction. Now, an individual who is Eve is someone who is interested either in the client or in the server. And what is the expectation? The expectation is somehow information about either Bob, that is the server, or Alice, the client. What will the adversary attacker gain out of it? Adversary, on identifying some private information of Alice, will surely be able to even ensure that Alice at least becomes an entity, it becomes a product. The information, the private information of Alice can be utilized by Eve so that Eve is able to monetize that information. And we know on social media, when there are followers in millions and there are lots of trials where people are unknowingly asked to be the followers of certain accounts. So in that sense, Eve is a responsible attacker. Eve is an attacker who is responsible for ensuring that the secrecy or privacy, the security and privacy which is between these two via some way is breached. So remember three entities: Alice, your web browser, instance of your web browser. You can log into 10 different sites at a time. Bob, web server. Confidential transaction between Alice and Bob is confidential because Alice logs with username and password on Bob. And there are thousands of Alice who have logged from different locations on Bob. And Eve is always interested in gathering private information about either about Alice or about both, about Bob or about both. So ultimately, what has Eve to gain? Eve gains money by breaching the security or privacy of Alice, Bob, Alice or Bob, or Alice and Bob both. So Eve is a very powerful individual. Why individual? Because ultimately individuals develop algorithms, individuals develop programs. So this is a very simple use case, a simple example of a threat model that we have to consider while we talk about security of web and basics of information security. This particular course will usually consider any book, say you consider William Stallings, you consider Forozan, you consider Atul Kahate, or consider anything. These three characters should be clearly embedded within your thoughts. Alice, your browser, an instance of a browser. Bob, web server. Eve, an attacker who is hell-bent on getting private information from Alice, Bob, or from both through one or the other way. And that attacker also gets this information in a polynomial time. Right? Important to remember. The time taken is comparatively slower within the bounds so that that information remains useful. An attacker always binds within what time Eve or adversary is able to gain the information. Now, what is the goal? When we see this threat model, where Eve is a threat actor, goal is to protect Alice's communication with Bob. So client's communication with server needs to be protected. This is the goal. And goal is when you develop a website, you will ensure that the users who log on to the website that you have developed for your client, the content of those users remain secure. The communication that happens between the users of the website and the website that you develop for your client remains secure. So how do we do that? Right? Important thing is Alice writes something which is called a message. So let me just put in a message for you. Let's say Alice, who is a client, has a name called Alice at gmail.com, and password is hello@10112. When you read this, it's a plain text. When something is readable, when someone is able to relate what is written, it is called plain text. So the fourth word that you need to remember, something whose meaning can be inferred, is a plain text. Now you have to remember this, or you have to remember what? You have to remember that whatever Alice writes, like this message, right? Either or, I love you or I hate you. This message is called a plain text. This message is one or the other way your username and password. Assume that. So when it travels through this public channel, there is no default security provided. Remember this. So you have to do something which is called, find a lock is assigned, which is usually known as encryption. Right? There is a word called N, so you do that. And you crypt it. You crypt it means you create a jumble from the readable plain text. So let's say the E, which is known as an encryption algorithm, which is a mathematical derivation, a mathematical model to ensure that I am not able to infer what exists. So when I say a dash, and when I say I replace this by so if you see this text now, instead of A, and if you assume that the first one is in hands of E, if Eve is able to gain access to this text, the above, then you are doomed, because your credentials are in plain text and this credential is already taken up. It's already with the adversary, is able to somehow get it. Don't know how. Right now, let's assume we don't know how Eve got it, but if it gets this, Alice can be you. Alice can be Eve, can be Alice. So an adversary can pose, an adversary can masquerade as a legitimate user called Alice. Similarly, take this case. Instead of this information, if an attacker gets this, instead of A, I wrote something which is called A dash. So if the attacker gets this, attacker cannot directly infer something or looking at the second text. Why? Because it's not a text which can be directly inferred. Though there are alphabets, though it's an alphanumeric model, still the attacker has to make some tangible effort, to get A. So in simple terms, I would say this is plain text. And what you see here, right? What you see here, whose meaning does not exist in a dictionary, is known as encrypted text. So to do that, you all are programmers, so you know that as programmer, you are aware that whatever transfers, right, transfers via an mechanism which is known as algorithm, but an encryption algorithm. When you convert plain text into a jumble text, it is encryption. So what is the outcome of encryption? I'm just giving a simple example. In case of A, when I run an encryption algorithm and if I get this here at this point before it is moved to public channel, then it is called either encrypted text. It is known as an encrypted text, or it is called crypted text, whatever you are comfortable with. Right? So content has got encrypted. Now, what is the advantage? The advantage is even if Eve, who is a very smart individual, who can make good programs, which can catch the information over this public network while it is traveling here. Still, when Eve gets this directly, Eve does not know what this information is because it is not readable. It is jumbled. Therefore, we say we applied an encryption algorithm. Remember this word. So an encryption algorithm was applied, and then the coded message, which is also called encrypted message, is actually put on the public network. What is the advantage? The advantage is even if attacker gets hold of this particular text, he doesn't know what it is. He will have to make a substantial effort within a tangible time to know what it is. But remember, he will put his efforts to do that. Now this content travels over the public channel, over the internet, and it reaches the destination. So client encrypts the content, sends it over the public channel, that is internet, sends it on internet. Now, since he is sending it on internet, it will reach the destination. So Alice is called source. Alice is known as a source, and Bob is known as a destination. Why Alice is called a source and Bob is a destination? Because Alice is a client, Bob is a server, right? So we and on web we are always in a situation which is called a client server situation. Now things should be more clear to you. So this content reaches Bob. Now what? When this content reaches Bob, the content has reached Bob in a manner which is not legible, which is not plain text. So Bob needs to first convert this into a plain text. Therefore, what you see here in the box, a D, is a reverse process. The reverse process is known as decryption. encryption. So when you want to convert plain text to ciphertext or encryption, you apply an encryption algorithm, E-algo. And when you want to gain the same plain text, that is again a ciphertext to plain text, then it is decryption. You are doing exactly the reverse of what you did. You converted plain text to encrypted text. Now, for Bob to understand at his end, he doesn't know what this jumbled password is. This was created so that on-way attacker cannot gain access. So now, when the content is decrypted, when it is to be decrypted, decryption algorithm will, the decryption algorithm will do what? It will do exactly the reverse of encryption. What did encryption do? PT, plain text, was converted into a ciphertext, adding something which is called a key. What is important? Even in your house, when you go out, do you keep your house open? Do you keep your home open? Usually no. You ensure that important places within the house are locked with a good lock. Your main gate, your veranda, your front gates, back gates are also locked. And you take the key along. So what is important? Important thing is the key. So when someone encrypts something, so let me say encryption is an algorithm. So what input does an encryption algorithm take? Encryption algorithm takes plain text as an input, adds a desired key, and applies an algorithm. E is an algorithm. So let me just give an example of an algorithm. CEA. Consider that E is your encryption algorithm. So I'm giving name of a algorithm which is called Caesar cipher. So Caesar encryption will require plain text. What is the plain text? The plain text is username and password of Alice. Or probably for the sake of simplicity, let me make it simple. The important thing is password. And let's say my password is something like this. Hello. So this password is your key. And password is a protected entity. It's a private information. So an encryption algorithm converts a plain text into ciphertext. Similarly, when it reaches Bob, when it reaches the server, decryption is a process that has to be executed. So decryption algorithm is what input does it take? It takes encrypted text as input, right? An encrypted text as input, which is I said it's a CT ciphertext. It takes ciphertext as input, applies the same key. Remember this word? This communication is a secret communication between two individuals. So what is important is the key. Alice and Bob both should have the key. If one of them does not have the key, it won't do. Also remember, the key has to be same. You cannot have two different keys to encrypt with one and decrypt with one another. No. This is the private encryption mechanism. This is an encryption mechanism which is also known as symmetric encryption. So when we apply decryption, just see, it will give you the plain text. So what did we do? Using cryptography, we ensured that the confidential information travels over the public network, ensuring security even if an attacker, who is also called an adversary, remember this word adversary, gets hold of the message. An adversary is a very smart individual who has developed some programs like you people do. And those programs have been constantly scanning the public network because it's a public network. So everyone are able to access that network. So in that sense, in order to protect the sanctity of PT, that is it is known as the plain text. So PT is converted to CT, plain text is converted to ciphertext by encryption algorithm, and decryption algorithm converts ciphertext into plain text using the same key. Remember this. Let me just write key 1, key 1. So not key 1. Let me clearly say K1. So this should be same at both ends, Alice and Bob. Only if it happens this way, then the information can be converted into secure before it travels or while it travels on the web. If you see this, see. So this communication is an encrypted communication. Now, let's go next. How cryptography actually evolved. So there is a book called The Code Breakers by David Kahn in 96. It would be very interesting for you guys to go through because you are in final year and probably some of you are going to be very good programmers. Some of you are going to join your undergrad program, and the people who are in diploma usually are thought of to be very good programmers. A very simple example, which all see something very surprising here. If you see this, Julius Caesar was a Roman emperor in the year before Christ, the era which was before BC, before Christ era, 44 to 100. So it was more or less 66 years, right? What did he do? He, at that time, before, I mean, we are into AD now, after the death of Christ, 2000 years AD, 2024 years or 2023 years have passed, 2023 years have passed, and we are talking about the era before Christ. So Caesar was a Roman emperor in the before Christ era, and at that point as well, he used a cipher which is known as the Caesar cipher, the example that I actually gave you. Right. What I wrote somewhere, if I wrote it somewhere, I am not very sure, but yes. I gave an example of something which is called a Caesar cipher. So what did he do? He did something absolutely important at that time. If you see, he says C equals M plus 3. Now understand, C is ciphertext. Don't consider this word as M. Consider this as plain text. Consider this as PT that I wrote. Right. So let me just give you a very simple example along with this so you will understand how it works. Say my name is, my password is hello at hello 1 2 3 4. Let me do hello OLL. Let's do this, right? All text. Now he says, now we have to, I said an important thing, key should be always 1 for both tasks. When you lock your door, you lock it with the key. So when you come back, you unlock the door with the same key. It isn't that some other key will open that lock. No, Every lock has one fixed key. Therefore, it's called a private encryption, or therefore it's called a symmetric encryption. So in symmetric encryption, remember that the key will always be 1. So K equals K plus 3 alphabet, PT plus 3. What does that mean? If my word is an H, what comes after H? I, J, K. So I'll just replace H by K. What comes after three characters after E? F, G, H, H, L, M, N, O, O, L, O. What comes after O? Three characters after O? P, Q, R, R. What comes after W? X, Y, Z. What comes after O? A big O. We have not actually differentiated between these two. So let it be R again. What comes after L? M, N, O. What comes after L? M, N, O. So now, if an attacker gets hold of this text, the one that you see is a plain text, which if someone gets hold of easily, he knows there is a message called hello WOLL, and this is a cipher text. You will actually relish one fact that between 444 to 100 BC, a Roman emperor was using encryption mechanism to send the messages, right? But what was important? The important thing was the key. And in key, it was decided, it was fixed that the character that you have, you will add 3 characters to it and replace it with the original word. So say if I have an A, B, and C. So I will, what will I do? I'll consider A, B, C, D. Let's only consider these 4. So consider A as 0, B as 1, C as 2, D as 3. So if we go by this way, if you have a Z, what is Z? Z is 25. You can never replace A by A because then plain text remains plain text. So now assume I want to do key as a plain text plus 1. It means A will be replaced by B will be replaced by C, and Z will be replaced by A. It's a round robin thing. If I consider plain text as plain text plus 2, PT equal key equals PT plus 2, then A will be replaced by C, B will be replaced by D, and accordingly O will be replaced by Q, R will be replaced by T. So what is important? Important thing is the key. Remember this. However good a lock is, however good an encryption is, if you keep the key available for the attacker, if you keep the key in know-how of the attacker needs nothing else. अटैकर को कुछ भी नहीं चाहिए, अटैकर को सिर्फ की चाहिए. So it's your duty to keep your key very private, right? So the example that I showed, the calculation that we did initially is an example of this classical encryption algorithm. No one uses Caesar cipher anymore, but when we start with some foundation course, we usually identify a lot of classical algorithms, though they might have become irrelevant now. This is how things began, right? So let me stop here today. A brief summary about what we did. Security and privacy is one of the most important aspects of computing. Basics of information security. This course is actually looking at a lot of things. It's looking at information security. It is also looking at network security. It is looking at cryptography, and it is also looking at cyber security. So 4 domains within one particular topic. So remember, Alice is a client who is your machine's browser. Bob is a server. Who is a server? Someone who provides services. So your Gmail is a server. Times of India is a server. Because that website is hosted on that machine, which is always accessible to you. When we communicate over the web, over the internet, remember, your communications are usually on a protocol called HTTP, which is stateless and unsecure by default. Web by default provides no guarantee. So remember 4 or 5 words: Alice, client; Bob, server; Eve, attacker or adversary; plain text, some alphanumeric text which can be understood by us. So now remember your passwords. You would usually keep your passwords which has some meaning, although you attach some special characters and numeric ones along with that. Right. Also remember there is something called encryption. You crypt it, you convert a plain text into a jumbled text. So if someone is an attacker, an adversary, if he or she gets hold of the information, he or she is actually not able to gain immediate access to your plain text because you made some effort to hide that information. When you decrypt it, it's a cipher text. Right? So remember this: plain text converted to encrypted text using encryption algorithm. Something very important with encryption algorithm is the key. Now your content is encrypted, so it can easily travel on web without the fear of being read by anonymous individual or an attacker called Eve. When it reaches the destination, destination always has to decrypt, convert that jumbled text into plain text. Right. And the methodology that we looked at, the way we try to understand this is via something which is called a threat model. So first thing in security that you need to remember is you have to explicitly create a threat model, identify the threat actor, and then create a use case to secure your information. In the next episode, we will surely discuss other aspects like important aspects such as symmetric encryption. Within symmetric encryption, we'll also take up a couple of things which are very important for us. Why very important for us? Because these fundamentals will propel you towards developing secure web, developing secure app, developing mobile app, or whatever desktop application you develop. Without requisite security guarantee at your end, it is less likely that the users will be able to access your information. Every user who is on web always requires a guarantee of security and privacy of his or her private communication. And if as a developer, which you already are, cannot guarantee, difficult to achieve. So remember that this course will actually help you to, for a lot of things. Achieve security guarantee, understand how security can be provided, and then embed that via your programming skills. Lot of things may already be existing in your programming domain. Lot of functionalities would be available. You just need to use it. But for that, you must know how to deploy security and privacy. So see you next in the next session. I'll keep posting these videos for your benefit. You can you can comment on the videos if you have specific requests. If you think you want to know more, keep following me. I'll keep posting the videos of this particular course, the complete course in due course of time. Thank you.